Hello everyone and welcome to Lesson 3-2 on Control Flow and Loops. Today, we are going to explore some of the essential concepts in Python that allow us to make decisions and repeat tasks in our code. This lesson will help you understand how to use conditional statements and loops to write programs that can react to different conditions and automate repetitive tasks. Let's begin with conditional statements. In Python, the if statement is the basic building block for decision-making. When you write an if statement, you provide a condition that Python evaluates. If the condition is true, the block of code that is indented under the if statement is executed. If not, the program simply skips that block. For example, imagine you have a variable named temperature set to 35. When you write a condition to check if the temperature is greater than 30, Python will evaluate it and, because 35 is greater than 30, execute the code that prints it is a hot day. This simple mechanism allows your program to decide what to do based on the value of temperature. Often, you want your program to choose between two or more alternatives. This is where the else and elif clauses come into play. The else clause provides an alternative block of code that runs if the initial condition is false. The elif clause, which stands for else if, lets you check additional conditions if the first one is not met. For instance, if temperature is set to 25, Python will first check if it is greater than 30, and since it isn't, it then checks if it is greater than 20. In this case, since 25 is greater than 20, it prints it is a warm day. Otherwise, if none of these conditions are met, it would print it is a cool day. This structure simplifies handling multiple outcomes in a clear manner. Sometimes, you need to perform extra checks within a block that has already been determined to be true. This is known as nesting conditional statements. For example, suppose you are evaluating a student's exam score. You might first check if the score is at least 50 to determine a pass, and then, within that block, check if the score is 85 or higher to see if the student achieved honors. So if the score is 90, Python will print pass, and then, noticing that 90 is at least 85, also print honors. However, if the score is below 50, the program will simply print fail. While nesting is very useful, it is important to keep your condition simple and your code easy to read. Another important aspect of conditional statements is the use of logical operators, such as and, or, and not, which allow you to combine multiple conditions into a single statement. For example, if you want to check whether a number falls between 10 and 20, you might write a condition that requires the number to be both greater than or equal to 10 and less than or equal to 20. In this case, both conditions must be true for the associated code to execute. Logical operators make it easy to express more complex conditions in a clear and efficient way. Now, let's move on to loops. Loops are used to execute a block of code repeatedly. In Python, there are two primary types of loops, for loops and while loops. For loops are ideal when you need to iterate over a sequence, such as a list, a string, or a range of numbers. For example, if you have a list of fruits like apple, banana, and cherry, you can write a loop that goes through each fruit and prints a message like I like apple, then I like banana, and finally I like cherry. The loop automatically moves from one item to the next until every element in the list has been processed. While loops, on the other hand, are used when the number of iterations is not predetermined. A while loop continues to execute its block of code as long as a specified condition remains true. Consider a scenario where you want to print the numbers from 1 to 5. You would start with a counter set to 1, and as long as the counter is less than or equal to 5, the loop will print the current count and then increase the counter by 1. Once the counter exceeds 5, the condition becomes false, and the loop stops. It is essential when using while loops to ensure that the loop eventually ends, otherwise, the loop might run forever. Within loops, there are additional control tools available. The break statement allows you to exit the loop immediately, even if the loop's condition is still true. For instance, if you are processing numbers from 0 to 9 and you want to stop once you reach the number 5, you can use break to end the loop as soon as 5 is encountered. In contrast, the continue statement skips the remainder of the current loop iteration and moves directly to the next iteration. This can be useful if you want to ignore certain cases, such as when processing even numbers, and only act on odd ones. Let's consider a practical example that combines these concepts into an interactive program. Imagine you are writing a simple quiz program that repeatedly prompts the user to enter a secret word. In this program, the secret word is stored in a variable, and the program continuously asks the user for input until they provide the correct word. As soon as the correct word is entered, the program prints a congratulatory message and stops asking for input. For instance, if the secret word is Python, the program will convert every user input to lowercase to ensure that the comparison is not affected by different cases. If the user types anything other than Python, the program will say incorrect, please try again, and continue prompting. Once Python is entered, the program will congratulate the user and exit the loop. It is important to note that these control flow mechanisms, conditional statements and loops, are not just abstract ideas. They are practical tools that allow you to build programs that interact with users, make decisions, and perform tasks automatically. Whether you are automating repetitive tasks, processing data in batches, or creating interactive applications, mastering these concepts will greatly enhance your programming skills. When writing your own programs, always aim for clarity and simplicity. Keep your conditions straightforward and avoid unnecessary complexity or deep nesting. Use logical operators to combine conditions in a way that is easy to read, and when using loops, ensure there is a clear exit condition to prevent the program from running indefinitely. Remember that adding comments to your code can also help make it more understandable for both you and others in the future. In conclusion, today we covered the fundamentals of control flow and loops in Python. We learned how the if, elif, and else statements allow the program to choose between different actions based on conditions. We saw how nested conditions enable more detailed decision-making and how logical operators combine multiple conditions effectively. We then moved on to loops, exploring how for loops iterate over sequences and while loops repeat actions until a condition is met. We also discussed the importance of the break and continue statements in managing loop execution. By integrating these constructs into your code, you can write more efficient, responsive, and dynamic programs. I encourage you to practice by writing your own small programs using these techniques. Experiment with different conditions and loops, and observe how changes in your code affect its behavior. The more you practice, the more natural these concepts will become, and soon you will be able to apply them effortlessly in your own projects. Thank you for your attention throughout this lesson. I hope you now have a solid understanding of how control flow and loops work in Python and how to use them effectively. In our next session, we will build on these fundamentals with more advanced programming constructs. Until then, happy coding, and I look forward to seeing what you create.